question 10, right? The question asks you to calculate change of gravitational potential, giving two few informations here. The first one will be the mass, 3 kilogram and 1 kilogram respectively. All right, released from rest, so initially it's not moving, with the mass 1 kilogram on the ground and 3 kilogram mass on a point 2 meter. This is the important 2 meter initially. Now calculate changes in gravitational potential energy when the mass, this time the 3 kilogram reaches the ground. So if you draw the diagram initially, so what we do is I'm going to redraw the diagram. Two mass, all right, not this mass, all right. So I'm going to redraw again. All right, square, and then I'm going to copy this one, the square. So this is initial one. So initially this is a situation, okay, this is the pulley, so this is the height. So initially distance between the height for 3 kilogram is 2 meter. This one is for 3 kilogram, 1 kilogram. So what we need to do is, if we want to find the change in total potential energy, the first thing we do is we need to find what is the total potential energy initial of a system initially. So the U total, this case involves two objects, object 1 and object 2. So maybe I'm going to label this as object A and object B lah. So I'm going to write down this one is UA plus UB, total potential energy initially. Alright, so in this case, since that object B is located on the ground, so the potential energy for this one will be 0. So I will end up with only potential energy for A. So if you expand this one, you will get mgh. So I'm going to substitute in the h value, since that we know it's 2 meters, so 2 mg. So this one will be our total U total initially. Alright, so after this, what I'm going to do is I'm going to redraw this diagram, but this time the object for A is now on the ground and object of B is now at a certain height. Alright, this is your A and B. Now A is on the ground, B is the height. So if this case, if you look at it, so if this one go down 2 meter, the object B will go up 2 meter. That means that the height here should be 2 meter too. Right? Now I'm going to calculate what is the final total potential energy. So final, so again I'm going to sum potential energy for A plus total potential energy for B. Now since that your A now is located on the ground, so the potential energy for A would be equals to 0. Only end up with potential energy for B. So I'm going to substitute in here, the height of B is 2 meter, 2 mg. Right, mass for B. Alright, this one will be mass for A. Alright, so once we have this one, now when we want to calculate what is the difference in gravitational potential energy, so the difference I'm going to label as delta U is equals to U final minus with U initial. So I'm going to replace U final with this one, total U final here, total U initial here. Alright, this is what I'm going to do. So U final total will be 2 mb G minus with initial will be 2 mag. Alright, so since that what we do is, because This is 2 and this is G, the same thing, so I can factorize it. So I can factorize 2G, so you will end up with MB minus with MA. So substitute in the value. So G will be 9.81. Mass of B is given in the question 1 kilogram. Minus with mass of A is given in the question 3 kilogram. So here I will end up with negative 39.24 joule. This would be my final answer, change in potential energy. Alright, that's all.